In this problem, I have n kids with candies. I get an array candies where candies of I represents how many candies one ith child has. I also get an integer value extra candies, which is the extra number of candies that each child will get. Let's take a look at an example. Let's say I have 5 children in candies. First one has 2 candies, second has 3, third has 5, fourth one has 1, and the fifth one has 3. The one with the most candy is the third one, so 5 is the max value. Then I give each child 3 extra candies. So the first child now has 5 candies, the second has 6, the third has 8, the fourth has 4, and the fifth has 6. Now I check if each child has more candies than the third child initially had. If he does, the answer is true. And if he doesn't, the answer is false. In C++, we can easily check this by using the max element function and the for. If I was to describe the steps needed to solve this algorithm, I would first need to declare a variable and the Boolean array result. Then I would give each child the extra candies value and verify if the new amount of candy that the child has is more than the max value which we calculated. And finally, I would return result. So first, I declare an integer variable which I named valMax. This variable holds the max value. I calculate that max value by using the function maxElement from the algorithm library. In general, this function gets 2 parameters, first index and last index. So it determines the max value of the array starting on the position of the first index going to the last index. MaxElement returns a pointer at which the max value element is hosted, and for that I use an asterisk. This is a specific C++ syntax. I would do a similar thing if I wanted the minimum element in the array, but by using minElement. I also declare the Boolean array result. My next step is to check the values after adding extra candies, so I'll use a for loop for this step. But in order to be very efficient with my code, I add extra candies and verify if that new amount is bigger than valMax, then store the Boolean answer of that in result, all on the same line. So my for loop goes on each C in candies. This loop is known as a range-based for loop. This type of loop traverses all the elements in a container like an array or any other data structure that supports intervals. The loop then adds extra candies to C and checks if the new C is bigger than valMax. Next, the loop adds that answer to result by using the pushback function. Pushback comes from the STL library and is generally used to add a new element at the end of a container. If the container doesn't have enough capacity to store the added element, the capacity of the container will be automatically extended to accommodate the new element. This can be simply a relocation of the existing elements in the container. In conclusion, to see if each child will have as many candies as the child with the most candies after adding extra candies, I first find the maximum initial candy count, then I check each child's candy count to see if adding extra candies makes it equal to or more than the maximum. The ultimate result is a list saying true or false for each child, showing if they meet this condition. And now, let's run this solution to verify that everything works properly before submitting.